All right, for the Zoom class for 831, I'd like you to write down each of these problems that I'm having you do and try. Write all of them down. All right, very first concept I want to really go over with you, other than reviewing order of operations, integer rules, is the difference between an expression and an equation. An expression can have any variables in it, could have any numbers, but it's not equal to anything. Looking at this is 4x plus 6. It's not equal to anything. It's not an equation, it's an expression. I could plug in any number I want for x, and as long as I follow order of operations in math, I'll get an answer. But any number I want, an expression not equal to anything. An equation has that same 4x plus 6 here in this example, but equal to 26. An equation, you could see, clearly has an equal sign in it, equal to something. An expression, no equal sign. An equation, equal to something. An expression, I could give you any value I want to plug in and do the math. I'll give you x equals 3. But for any equation, there's only one answer for x that I could plug in and do the math times 4 and add it to 6 and get it equal to 26. For an equation, there's only one solution until, of course, we get to quadratics, but a regular linear equation, only one answer for x. An expression, I could plug in any number I want. If I wanted to evaluate when x equals 3, I would just leave that 4 alone, and where 3 is, I replace that x with 3. I'm using parentheses here to show times. That 4 times 3 is the same as 4x, that's times. 4 times 3 plus 6, that gives me 12 plus 6, which gives me 18. So that's just the value of the expression when I plug in x equals 3, the value of that expression when I evaluate for x equals 3. For this equation, to solve for that one answer for x, remember they were taught your inverse operations to isolate this x. I'm going to get rid of that 6 first by doing the opposite, subtracting on both sides. So we'll cancel away. I'm going to bring this 4x straight down, and my equal 26 minus 6 is 20. Right here, this is 4 times x, so the opposite of timesing by 4 is dividing by 4 on both sides. That's how we show division. These 4's divide away into 1. Most people don't write 1x, they just write x at that point. And then that answer equals 20 divided by 4. That gives me 5. That is the only answer to this equation. That's the only number I could plug in and get a true statement. In an expression, I could plug in any number I want and do the math. An equation, there's only one answer that I could plug in and get a true statement. If I take that 5, and make sure you're writing down everything I write here, taking that 5 and plug it in right there for x, that will give me 20 plus 6. That gives me 26. That is a true statement. That's what happens when I plug in a variable that is a solution to that equation. All right, let's keep going. First problems out of the module. These are problems from module 1-1. That's what we're looking at today. They start off with single variable equations, where on these they're giving you 3 possible values for x to plug in. Only one of those is a solution to that equation. If I was to take that 3x, and I am going to have you write this down, I leave that 3 there, but where that x is, I'm going to replace it with this first value, -2. Leave that parenthesis there, plus 7. And let's see if that math gives me an answer equal to 13. This gives me -6 plus 7. That's equal to 1. 1 is not equal to 13. X equal negative 2 is not a solution to that equation. Let's plug in x equals 2. Next one. If I plug in x equals 2, I have that same 3 there, but this time where x is, I'm going to replace that with positive 2. That gives me 6 plus 7, which is 13. That shows that x equals 2 is a solution to that equation. Yes, that one works. Let's plug in x equals 5. Plug that last one in. When I plug in 5, that gives me 15 plus 7. That gives me 22. That is another false statement. X equals 5 is not a solution to that equation. Okay, real quick, I'd like you to try this one on your own. 8 minus 2b equals negative 2. I'd like you to plug in negative 3, plug in 0, plug in 5. I want you to be doing this in your notebook. All right, if I plug this in, I have 8 minus 2. And for this first value, they want me to plug in b equals negative 3. So where b is, I'm going to plug in negative 3. That gives me 8 plus 6, which is 14. And that is not equal to negative 2. B equals negative 3 is not a solution. If I plug in 0, I have 8 minus 2. And this time where B is, I'm plugging in 0. Gives me 8 minus 2, which is 6. And you can see that is not a solution. B equals 0 is not a solution. Let's plug in 5. So I have 8 minus 2, and where B is, I'm going to plug in 5. That gives me 8 minus 10, which is negative 2. So you could see B equals 5 is a solution to that equation. None of the other B values, negative 3 or 0, those are not solutions. Only B equals 5 was a solution. All right, let's keep rolling. Next problems are these two. And again, write this down in your notebook, separate from your packet. Sometimes you have variables or an equation with two separate variables, x and y. We need you to know that ordered pairs, coordinates are written with these parentheses and are always alphabetical. That first number is x and the second number is y, always alphabetical. First value is x, second value is y. For these problems, what they're having you do is realize this equation has two variables. This coordinate that we're giving you gives you the x number to plug in and do the math. But when you do the math, the y value is what gets spit out. So let me show you this first one here. It's saying take that x is 8, and where there's an x, plug that 8 right in there. So I'm going to replace that x with 8. So here I go. I'm going to get y equals 6. And in that parenthesis there where x used to be, I'm going to plug that 8 number right there. Pays to have a calculator. That gives me y equals 48 minus 15, which gives me y equals, I believe that is 33, which tells me that when I plug in x is 8, y gets spit out as 33. Rewrite those as coordinates, always coordinates, where the first number is the x number and the second number is the y number. So this is going to be the coordinate 8. The x number got plugged in, y was 33. If I do that again, the second one has me plug in x is -1 and find out what that y number is. So I got y equals 6. And where that x is, I plug in -1 right there. And that gives me y equals -6 minus 15. Combines to give me two negative numbers, an even bigger negative number, -21. So I could see when I plugged in x is -1, y -21. If I was to write that as a coordinate, the x number, the number I plugged in, was -1, and the y number that got spit out after doing that math was -21. So again, equations with two variables, an ordered pair gives you half the coordinate. All right, last one for this. You got y equals 6. And where that x is, I plug in 5. Gives me y equals 30 minus 15, which I believe gives me 15. So that coordinate, again, coordinates always written x and y. The x number was 5, and the y number got spit out as 15. So that pair gives you a true solution to that equation. All right, I'm going to shrink this down. I would like you on your paper, separate from the packet in your notebook, separate piece of paper, I'd like you to try this one where I give you the equation y equals -4x plus 9. I'm giving you the first value for x. I want you to plug it in and see what y is. So I'd like you to try this one right here. All right, hopefully to get you rolling here, y equals -4, plugging in for x, -5. That gives me y equals 20 plus 9, which is 29. So that coordinate, when x equals -5, y is 29. If I was to plug in this whole coordinate into this equation, it would give me a true statement. If I plugged in 29 for y, and I left that -4 alone, and I plug in that -5 for x, this is going to give me a true statement. That coordinate, that ordered pair, is a solution to that equation. That gives me 29 equals 20 plus 9. 29 equals 29. Shows that point, that coordinate, is a solution to that equation. That's what you're doing when you're plugging in the x number and getting the y number after you do the math. That coordinate is the ordered pair solution to that equation. If I was to keep going, again, just plugging in x, solving for y, that gives me y equals -4. This one has me plug in +2. That gives me -8. That gives me +1. So that one, when I plugged in x is 2, y equals 2. And again, you could write those coordinates just like that. You can write the coordinates under here. When x was 2, y is 1. I'm sorry, that should be a 1 up there. And then the last one, if I plug in 4 for x, I have y equals -4, and where that x is, I plug in 4. That gives me -16 plus 9. -16 plus 9, find the difference of the two, keep the sign of the bigger number. Gives me -7. So that one, when x was 4, y -7. Again, writing that coordinate for x and y, the x number always first, y number second. When x was 4, y is -7. That point would be a solution to that equation if I was to plug it in. Okay, let's keep going. Second to last thing are ordered pairs. Again, if we give you a table with ordered pairs, we need you to know that these are coordinates to write down. Coordinates are always x first and y second. The way we do an x and y axis, we always label the one that goes up and down. That is the y axis. Y goes way up high into the sky. The x axis is the left to right axis. So I'm going to number each box. First one is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Label the y-axis boxes. That first one's 0. First line 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Again, when you're writing these coordinates, that first one, 0 for x, the y number is 3. That's that coordinate pair right here. Next coordinate pair, 2 for x, 7 for y. Again, these list all the x numbers that go first. This lists all the y numbers in the coordinate that goes second. So again, that first pair, 0, 3, 2, 7. The next pair, 3, 9. And then the last coordinate pair from this table is 5, 13. And again, when you graph it, start at the middle. Let that x number tell you how far to go to the right. So I'm going 0, not going anywhere. The second number in that coordinate 3 tells you how far to go up or down. So 0, 3, 0, and then go up 3. That's the coordinate 0 for x, up 3 for y. If I do 2, 7, right 2, and then up 7, 1, 2, 3, 4, 5, 6, 7, that is the coordinate 2 for x, 7 for y. If I plot 3, 9, go over 3 on the x-axis, and then go up to 9 on the y-axis, and then 5, 13, right 5, up 13. Don't have to draw a line through these. I'm just going to label these to let you know that's the coordinate 5 is, x is 5, y is 13. This is the coordinate 3, 9. This is the coordinate 2, 7. This is the coordinate 0, 3. All right, I'd like you to plot these coordinate pairs. Remember, The first one's X, second one's Y. Always alphabetical. It helps sometimes to write these as coordinates so you could take the data from the table and write it clearly as a 0 for X, 14 number 0, 14 coordinate. Okay, your X numbers, I'm going to count 0 to 10 again. The Y numbers, I'm going to count. So when I plot them, 0, 14, 4, 10, 7, 7, 9, 5, 0, 14, 0 for X, 14 for Y. 4, 10, right 4, up 10. 7, 7, right 7, up 7. And then right 9, up 5. Those are the 4 coordinates from that table. 0 for X, 14 for Y, 4 for X, 10 for Y, 7 for X, 7 for Y, 9 for X, 5 for Y. Remember, always the X-axis is the left or right axis. The Y-axis is the up or down axis. All right, last problems. Here we go. Tables, you need to come to grips with the fact that we'll be using lots of tables. You need to be able to read the words and kind of understand the math, what it's talking to you about. Again, big part of this section are tables. If you look at this first one here, it says you spend $600 to start your business, and it costs $5 for each birdhouse. So if you look at this table, if I built one birdhouse, the total cost was not $5. That was just for one birdhouse. That doesn't take into effect that I had to spend $600 first. So again, after one birdhouse, this is really $605. That's $600 plus the $5 to build a house. My next one will take that $605, add one more 5 to it, $610. The $600 I originally spent plus $5 for each birdhouse, that extra $10, and then keep going up. You could see I'm going up by 5s. My explanation, you could say I started with spending $600, went up by 5 each time. And we're going to start in this class to recognize that, again, that number you're going up, that plus 5, that is a very important number for these tables. Going up by 5, going up by 5. You need to know that if you're going up by 5 to the right, you're going down by 5 to the left. So we'll be looking at the fact that if I built 0 birdhouses, spent 600, you need to be able to do that kind of math. That math is coming. All right, next table says you make $15 payment for your loan of $500 each month. So after 1 month, again, you got to be real careful. After 1 month, you wouldn't owe $15. That wouldn't be right. After 1 month, you wouldn't owe $500. because that's how much your original loan was. You need to see that after 1 month. If I take away 15 or 500 minus 15, that this was 485. That's how much I spent, or that's how much I owed after 1 month. If I take away 15 again from that, 470. If I take away 15 again from that, 455. Take away 15 again from that. Helps to have a calculator. Take away 15. Take away 15. Take away 15. So explanation was, I started owing $500 and paid $15 each month. And again, looking at these tables, this one's different because this one is going down by 15, down by 15, down by 15, where this one up here on top went up by 5, up by 5, up by 5. That's an important subject. And then again, if I went back to the 0 month, you could see this table is going down by 15. If I go up, that would be 500. So at 0 months before I paid anything, $500 is what I owe. So again, tables, these are a big part of the math for this class. Okay, what I'd like you to do is in your same notebook or on that same piece of paper, I'm going to give you these problems to do. You could write them down and do them, or you could print out the PDF link I'll have here for you to print them out yourself. But I'd like you for today's assignment, I'd like you to do these 4 problems and submit your work for me. So do these 4. I'd like you to take the first problem here where there's only one variable in this equation. I want you to see which of these numbers work. Will x equals 2, if I plug that in, will that give me an equation equal to 10? Or if I plug in -2 in there, will that give me the math that equal to 10? Which one of these is a solution? For the second one, again, this equation has x and y in it. For these, I'm giving you the x value to plug in, and then I want you to do the math and see what the y value is that completes that coordinate. These x and y coordinates, remember, these ordered pairs are the solution to that equation with both x and y in it. The one on top, there's only single variable, only one of those x numbers is a solution. And then for this next one, I'd like you to say that you're starting with $250. That's how much you have to pay right away. And then you're paying $50 for each doghouse. So I want to know, after 1 doghouse, the total cost you spent. After 2 doghouses, the total cost you spent. And then I'd like you to take these and write these as ordered pairs, ordered pairs, ordered pairs for x and y, and plot them. Ordered pairs always x, y. I want you to know that this is the x-axis, this is the y-axis. All right, I'd like you to do these, submit these right away as soon as you can. If there's time, we'll have time to look at some of them. Look on my Canvas page. I should have a perfect example of this to show you. All right, good luck.